Hi, welcome to part 7. Before I get started, just a quick reminder that in part 6b you might have missed, I made quite a few changes. The main thing I did was, in my matchsticks and physics process, I basically bundled everything into its own function called move card. Everything's a bit more streamlined. In this part, what we're going to do, we're going to add it so cards can now attack each other and they'll also retaliate. The main way we're going to do it is this guy can only attack guys in the same line as him. So make sure he can only attack this card here, and he cannot attack this card here. Also program in that sort of bit of code as well, to make sure I can only attack cards that I am allowed to attack. Okay, let's get started. First thing to do is really quick. We've got these card slots here. Notice they're slightly not properly aligned. I think they're sort of more aligned to the left-hand side. We're going to quick fix that first to have them in the right place. Okay, so we're going to need a variable called slot shift. That's depending on how big the card is. For this, I need the size and also its scale. So add a variable called slot shift, and that's going to depend on the width for each card. I'm going to take that away from the size of each card. And to get sort of the in-game size, you've got to do the size times by the scale. If I just minus this and added on this bit of slot shift, that's it from the left-hand side to the right-hand side. What I want is just half of this value here. So a quick shortcut in Godot. If you highlight the whole thing is typed in brackets, it'll put the whole thing in brackets for you. So that divided by 2. And lastly, don't forget you only want the x coordinates of this size and this scale. Then we're done. If we just add that slot shift to my rectangular position, that would change it so now my card slots are nicely aligned in the middle, which is looking a bit better. Next thing we do really quickly is you should have these little enemies or bases scaling properly before they're just scaled by a random factor of 0.3, which made it look kind of right. So up here I defined a card slot base width and to make sure it appears to be that size. Do that times by card slot base width and then divide by the size it currently is. So enemies left, and it's just that rectangular size. And of course everything's the next coordinate, so on the x value of this. We then do the exact same thing for the base on the right hand side. But of course here I want enemy right. Okay, so now it'll be adaptively scaling, so if I have big or smaller pictures, I don't need to recode my scaling thing. So they're a tiny bit wee. Let's change a few numbers to make it look a bit better. Changing a few of these numbers to make it look a tiny bit nicer. Okay, that's done. Now we're on to the main thing, which is having cards highlight which cards they can attack. To do that, I'm going to go into my card base scene, and I'm going to add a border. So in my card base, you can add a child node, that's going to be a sprite. I'm going to call that highlight border. It's going to highlight whenever we can attack it. I need to throw a texture in for that. I'm just going to use the card border I've had before, this gold border. I'll just use that again. Again, don't forget we don't want it centered. And also for this, I don't want it starting as visible. Okay, first thing to do, very obviously, is rescale it so it's the right size. We've done that absolutely loads in our ready function. So let's find that bit of code. That's over here. I'm going to use the exact same code that I had for the border. So now it's the highlight border. And otherwise it's exactly the same. So now we're going to say whenever we click a card, if we can attack a certain card, you want to highlight that card to show that yes, it can be attacked. Okay, first thing I should have done for my highlight border, I want to have a z-index of 1, so this border always appears above the card itself, so it sort of highlights out and sticks out. Into our card base script, we've got a few things to do. I'm going to add a couple of functions. I'm going to add one function to make it visible, and one function to make it invisible. Okay, so what we want these functions to do is just get to that card and make it either visible or invisible. So get node highlight border. I think it's just not visible. So to make it visible, we want that to be true. And to make it invisible, we want that to be false. So now if I call those functions, it's now going to put a little border around the outside of it. Okay, what I'm going to do now is going to add a bit of code here That's going to say when I click on a card, if it's in play, I want it to find which targets I can attack and then highlight for them. So I'm going to say if my card's in play. So if the card's in play, I want you to find targets. And we're going to let a function out, it's going to do that for us. Let's add it up here. Function find targets. As we're going to search for the whole sort of card slots and see what targets we can possibly attack. Any that we can attack, we're going to log down its position, which card it is for later attacking it, and also tell it to highlight that card. So first we set some variables. First I'm going to have a variable called base target, which is when I can attack the base itself. Before I do that, I'm going to add the exact same invisibility and visibility code to the card base. So we need the exact same lines of code that we had in card base down here. Which of course means I need the exact same border as well. Okay, and in here that sort of card size we only decided we want it to be, which we defined earlier as being the rect min size. Okay, and also don't forget to highlight border, that should always be defaulting as invisible. Okay, so back to setting up our variables. We're going to say we're going to call the next row occasionally, which is our next row of cards. We're going to have the next row count, as in how many next rows have I called. We're going to have saying if there's an enemy in the way. So if an enemy is in the way, we therefore cannot attack the base. We're going to have a start or finish variable. That's going to tell us when we're in the range of card slots. And we're also going to have a list of targets that we're going to keep track of as well. Okay, we're going to make you two cases here that depend whether the card I'm clicking is the left hand side or in the right hand side. So if we're the left hand side, we're going to define my next row to be the card slot number, which is the card slot it currently occupies. We can see this isn't defined yet, so let's add that as a variable. And we're going to say when I click on a card, which is this bit of code up here, we're going to say the card slot number is just going to be I. You see up here, that was the card slot we're looking at to see whether it would fit inside it. Next thing to do, so we start with the card slot number. On the left hand side, I want to add on the next row. So next row count times, I'm going to times it by how many rows there are. So to do that, I need to go up 3 nodes now and call the number of rows. Okay, we can also define where the start or finish is. If I am on the left hand side, I know I've finished when I've gone all the way through to the right. It's going to be 2 lots of the number of card slots per size minus 1. So again, we go up 3 nodes, call card slots per size, it's going to be defined in play space, and then minus 1. Because again, we always start counting from 0 here. Then on an else loop, we basically do the exact opposite. So copy these both down. Here, if I'm on the right hand side, I need to subtract to get to my cards on my left. And I know I've finished when I've got to the card that's in the 0th position. We're now going to loop through everything, we use a while loop. So we're going to say while next row is greater than 0 from here, or it's less than this number here. So now it's only going to run this bit of code to look for cards when I'm in the range where cards exist. We then need to know when I am on my opponent's side of cards. So let's get this code working, let's run it so I can say what I mean. So if I've got a card here, the next row will be this card and this card. Both of those are valuable targets, so I can attack each of those. However, say my guy is over here, I cannot attack this target because it's on the same side as me. So I only want to trigger this code if I know I'm on this side. So I want to say if the next row minus start or finish is less than or equal to the number of card slots per side, that will tell us if I'm in the opponent's half. I've got to be careful, because in some cases this will give a negative answer, which of course will always be true. So I want the absolute value of this. So this bit of line will only trigger if I'm in the opposing half. We then need to have a look for cards. We're going to go up 3 nodes to my play space, that's where I store the log of what card slots are empty and what card slots are full. So if that card slot being empty is false, in other words, if there's a card in it, we can now basically log where it is and highlight it as well. So first I'm going to do, I'm going to say enemy is in the way. That's basically going to tell us later on that we cannot attack the base. I'm then going to add a new variable, and that's going to basically keep track of a list of targets. So say from a list of targets, we'll add a new guy at the end, so we're going to append a value, and that's going to be the card slot's position, and then after that also the card slot size. So we need to go up, we need to go into our card slots node, which is where all the card slots are kept up here, and we want to get the child with the corresponding number that we're looking at. So get the child next row. And from that child, I want to call its rectangular position. And then I'm going to do the exact same thing again, but then I'm going to look for the size. If I have the position and the size, I then can tell whether or not my mouse is inside it. Okay, next thing I want to keep track of is I want to know what card is going to be in that card slot. So again, I've got cards that are here in my cards node. They'll then also be in a card slot. So now I'm going to add a new variable in my play space, which is going to keep track of which cards are in which card slots. So in play space, we're going to have a new function down here, and that's going to find the cards that are in play. For that, I'm going to pass two things to it. I'm going to pass the card slot number. I want to return the card number that corresponds to it. So again, card slot number and card number, they are different things. To do this, I need to create an overall log. So I'm going to have another function, and that's going to update the cards in play log. So to create this log, I'm going to update it whenever I add a card to being in play, and those find cards in play will then return what cards are in each card slot. So here I'm going to also log the card slot number, and then I'm going to say whether or not I'm adding or taking away a card. To do this, we're going to add that log. So cards in play log is going to start off as blank. I can also be kind of clever. I can just say the child number is going to be 0. That's going to be the child number that goes into this playing log. So as soon as I put a card into play, I'm going to run this function. The first card that is a card in play will have child number 0, second child number 1, and so on and so forth. So we're going to say if we're adding, we're going to add in information linking that card slot number and also the child number. So vector 2 of the child number and the card slot number. And I'm also going to say my child number now needs to get 1 bigger. Okay, so if I run that, that's basically going to add a log saying that this child number in cards in play corresponds to this card slot. I then want an else loop, and I'm going to say, so this is if we're removing a card. So in that case, say a card's been killed, has to go to this card pile, we then want to move it from this log. And to do that, I'm actually going to call this find cards in play function. So let's write that now. So to find a card in play, it is just going to loop through all the cards that are in my cards in play log. And we're going to say that if the card slot number matches, we then want to return what card number that is. So the card slot number was kept to the y coordinate, the second vector. And I want to see if that's the same as the card slot number. So now we've found the card. We've basically got two cases. If I want to return the card number, which we'll do when I'm attacking it, I'm then going to say return that card number pretty much, which was the same thing here. It's going to be an X here. Else, which is the case if I'm up here, I just want to return what entry I was. So I was the ith entry here. Now we've done that, we can break out of that for loop, and that's it for this code. So back up to updating cards in play log. To remove it, I will have the card slot number. So I'm going to call the find cards in play log. I want to find that card slot number. I don't want its cast number, I just want it where it is in my array. So therefore this is going to be false. And they'll basically say it was the second entry. So I'm going to say, okay, now delete that second entry. That's a bit confusing, but it will come in really handy in a few minutes' time. Now I'm going to use this function. So we're going to my card base, and basically whenever I put a card into play, I want to run that function to update that log of what cards are in play. So that is done here. And we're now going to say, go up 3 nodes to my play space and update my cards in play. Okay, we need a card slot number. That was just I. And I'm adding, so that is true. We're going to later say that when a card dies, we want to remove it. To remove it, we're going to change that to a false. So now up here, when writing my find targets code, I can now use that to find what target is associated with it. Next thing I want to append is going to be the child number. So to get the child number, we're going to go 3 nodes again. And we're going to say what child in cards in play is that. So for that, we're going to use the find cards in play function. The card slot number is the next row. That's the card slot we're currently looking at. And I do want to return the card number, so that is true. And again, we just want to append on the child number. So that means for each card we can find in our way, we're going to add 3 pieces of information. We're going to say where it is, and also what child number it is. So if I want to attack it, I know which card to attack. Okay, next we can add our new function. We're going to highlight that function by giving it a border. So we're going to go 3 nodes. So we're going to go 3 nodes. We're going to go to cards in play. We found the child number, and we're going to say make that card visible, make it highlight up quite nicely. Also, I'm going to add a new variable actually quickly. That is going to say that a card is visible. So basically, whenever I let go of a card, I want it to know that I've made a card visible, I've added the border to it, so therefore please get rid of that border. So we've looked in the next row along. Where I find something we haven't, either we look in the row after that. So if on the left hand side, we basically want to copy this line here. And if on the right hand side, we want to copy this line here. So we'll look in the next row. Before we check that, we can improve this. So any card I click would already be in cards in play. So I can just say just go up 2 nodes. I'll take it straight to cards in play. Then if I get its child number, because of the last part of 6b, we're going to get the dummy node. So we're then going to say we want to get the node of card base. And also up here there should be an AND. So we want to run this while loop if the next row is bigger than 0 and also less than how many card slots I've got in play. So let's check that. If I drag 2 cards in play, when I click on one, the other one should be highlighted nicely. Of course it's not, that's because I very foolishly not yet enabled that bit of code to run. So these 2 lines here. Okay, and we see whenever I click on one card, it's highlighting the card, however it's not making it invisible again. So that will all be happen in if event is action release code. If I add that, let's do a few more changes to this. We've got one more thing to do, and that is the case if we find no cards in the way. So if no cards are in the way, that means no enemies are in the way, which therefore means I can attack the base. So if there are no enemies in the way after this while loop, we now know we can then attack the base. Again, we've got 2 cases, the left hand side and right hand side. If we're on the left hand side, my base target is going to be the enemy on the right hand side. So go up 3 nodes, call enemies, and then enemy right. Else, and then the exact opposite, we've got the opposite target, which would be the one on the left hand side. Next one, to get to my target, I want to make it visible. Again, we added that code into my enemy play, which is just down here. We also want to say that other cards are visible again. So we're going to use that second to tell us when to turn all those borders off. We can attack the base. That'll be useful in a second. Let's define it as a variable. And just as we did before, I want to add that to my list of targets. So I'm going to append three things again. First is going to be the position and the size. Lastly, I would append what child number it is. Of course, I don't need to do that because that's already defined by enemy right. How to keep my code nicer, I want to make sure that each target we find will always correspond to exactly 3 entries. Well, depends on infinity. Just so it's clear to me that what we've got there is going to be a base and not a certain card slot number. Okay, that code's all working now. Next thing to do, as I've just said, so when I release my mouse, so down here, we want to make all the targets invisible if there are any that are visible. So to do that, I'm going to look at my, whenever I release my left click mouse button, I've got a loop down here, which handle cards once they're in play. This probably will go fairly soon, we'll give it for the time being. We're going to say if there are cards visible, if we can attack the base, or if we could attack the base, we're then going to say get the base target and make it invisible again. If not, we now have highlighted certain targets, certain of my cards, so we can go through each of those and make them invisible. Okay, so if we're not attacking a base, we're going to run a for loop, and we're going to say for every single card that's in play, just make sure you're invisible. So for this, I want to go up 2 nodes. I want to ask how many children you've got. And for each of those, I'm going to say make it invisible. So that's going to be roughly the same code actually as what we had up here when you made the cards visible in the first place. So we can just copy that and use that again. Except here the child number is just I. And rather than make them visible, we're making them invisible. Okay, so now whenever we click a card, so now you put a card into play. If I can target the base, it will highlight it. If I can target another card, it will highlight that. Okay, the reason that's not working is even though here I do say make those cards invisible, the problem is every single frame I'm looking for targets again, which then makes them visible again. So what I should have done, I should have a new variable here that basically says I can only look for targets once. So found targets is false, and I can only look for targets if I haven't already found them. So then also need to say that once I found my targets, then found targets is true. I of course need to reset this. So whenever I release a card, when I'm in play, I'm going to say found targets is false, so I can find them again. And before we check that, don't forget that once we said we can attack base, we then need to say for a future time, for when we look next, we want to say can attack base always starts off being false. So let's check that's working now. So first, if I click a card, we highlight the base. Next, there were some cards in the way, it should highlight both of those, and then unhighlight them. And again, same working for the other player's team. And again, also, if I click this, it shouldn't highlight the guy on his own side. Okay, that's the first half done. That's most of the hard work, to be honest. Next, I had a bit of code that allows us to attack cards, and for them to retaliate or attack us back. We also had a bit of code in for cards dying, which is when the health gets to less than 0. Okay, to do that, do this first. We're going to add a quick function. What the function is going to do is just allow us to change the health of a card. So function, change health, and that will just change it by a number. We've defined health ages ago. Okay, it's currently saying health isn't defined in the code. Let's investigate that. And the reason for that is defined in my ready function, which it kind of believes doesn't exist as a real scope. So let's change all of those to onReady vars. Also, I have these defined as strings. That's probably not overly helpful. So let's just delete all those strings, and let's add the strings back in here. Okay, so now health is defined. So now here it can change the health with respect to whatever number we're passing through to it. We then also we have to tell the code to display that on the card. So back to our ready function, we had this line here, and we're just going to run that the exact same before. So it's going to basically redisplay that the health has changed. Going to update the health. We then need a bit of code here that deals with the fact of untimely and unfortunate death. So if health is less than or equal to 0, we want to do some stuff here. This will keep it fairly simple. We're just going to say move the card to discard. State is move and drawn card to discard. What we need to do after that, I need to do two more things. First, we had a card slot number. The idea that card slot being empty is now true again. And lastly, whenever I put a card into play, I of course updated that card log. Let's find where that is. And I want to run it again, but this time I want to tell it to remove that card. So the card slot number is card slot number. And if I have that as false, that's basically saying remove it. In other words, don't add it to the list, take it away from the list, which again we added earlier. So we have that function now. We can now use that function, and we're going to do that whenever I release my less click once I'm in play. So all this old code was to deal with attacking enemies. For the most part, we're going to just get rid of all of that. What we're going to say, we want to loop through everything I can possibly attack. So for I in the range of my list of targets. Again, for every single item, we put in 3 pieces of data. I think it was its position, its size, and what card number it was. So in loop 3, we have to divide that by 3. We're then going to say if my mouse position is within that card. And we're going to see if my mouse position is within the borders of each of those cards. So I want my x coordinate to be... Actually, I've already got this bit of code. This bit of code is the exact same thing, near enough. We run over here. So let's copy that down and then just change a few things. So instead of card slot position, that is going to be list of targets. And because that is my first term of the 3, that would just be 3 times I. Remember, this works because we start at the 0th number. Next, you want to add on its size. So the size is the next piece of information in my array. So I just +1 to this. So that's saying if it's less than the right-hand side, I want to make sure it's greater than the left-hand side. Which is done there. So anywhere I see card slot position, I can just replace with list of targets 3i. Everywhere I want card slot size, I need to add 1 to it. So now this will tell us, this will tell me whether my mouse is within any of my targets that I can possibly attack. So we've got 2 cases here. If we are attacking another unit, so if can attack base is false, which means I'm attacking another unit, I want to change the enemy's health and also change my health according to its retaliation value. So let's change our health first. So change health, and we need to get its retaliation value. So to do that, we want to go up 2 nodes, which will take me to cards in play. And I want to get the child, and I want to give its child's number, which of course I have stored here. And it's the next one along, so now it's 3 times I plus 2. From that, don't forget we have to get the node of card base. And we want to call its retaliation value. Okay, we also want to do the exact opposite thing. We want to get that target. And then you want to change its health according to our attack value. So that covers the code if we're attacking another unit. If we're attacking base, it's roughly the same thing, except the base can't do retaliation damage to us. So base target, and then just change its health according to our attack value. And last we need to do, it turns out we do need to define a mouse position. This works. We've got one slight problem, which is that the discard, move drawn card to discard code is not working properly. So my target position here should just be where the discard pile is. And then fingers crossed that bit of code should be working. We've got one more tiny thing to do if it is. So this guy does 2 damage, so knocks off 2 damage here, and if he attacks the archer twice, that should kill her and should head to the discard pile. Which he does, perfect. Here, whenever I reset a card, I should only reset it to being in play if that card is still alive. So if health is greater than 0, I can then do all of this stuff over here. Last one to change really quickly, or add on really quickly, is you notice it's kind of quite hard to see the health of the card. That gets quite small. So we had a bit of code that allows us to zoom in on the card to properly see what's going on. Okay, first thing I'm going to do, I'm going to add a new state to my list, appropriately called Mega Zoom. We're going to say if we can zoom in, so if Mega Zoom in, we then want the same loop we've always got over here. This one, let me pick this one because it's nice and blank. We'll do it fairly quickly, so we'll have the zoom in time. This state is Mega Zoom. My target rotation is 0, I don't wish it to rotate at all. My target scale is going to be the original scale, and then we're going to times that by the mega zoom in size. And then if that works, if that code completes, we then say mega zoom in is false, so don't keep running the same bit of code again and again and again. Okay, let's add those variables that's yelling at me about. So first we need to go to my enum and we need to add in a thing called mega zoom. I'll do the same in play space as well, just because I need it later on. It then wants mega zoom in. So I can start off being false. And then we also need mega zoom in size. And we're going to say here I want to make it 4 times as big. Okay, so the same idea we had zoom in size being 2 down here. Let's call that now. Let's see how we can use that. So we're going to say if a card's in play, it's one of my card slots. If I right click on it, I want it to zoom in. So let's go to Project Settings, Input Map, and let's add a new card called right click. And I just want that to trigger on my right button. So down to our input map, we have a new thing saying if event, we'll say if it's released. We then want to deal with a mega zoom in code. So first I'm going to say, if my state is mega zoom in, as in if I've got a card that's zoomed in, I want it to reset. To do that, we can add a quick function called undo mega zoom. Let's throw that up here for the time being. We then want to say if instead my state is focus in hand, and also as well if the card is in play, because I don't want to zoom it in when it's just in my hand at the bottom. We then want to do the mega zoom in. So we're then going to change the state. We're going to say mega zoom in is true. We want it to come to the front. We want to be in front of all the cards. So for that I can change my Z index. So that's up 1 node to my dummy node. So next to me 10 times bigger. Just so it's definitely come to the front. Let's just say setup is true. And we need to define a target position. Center around the dead center of my window, of my screen. So for that, I'm first of all going to get the viewport size. And I want half of that. I then need to adjust it based upon how big that card is going to become. So to do that, we know originally it's going to be the original scale times by its default size. And of course it gets bigger according to my mega zoom in size. I don't shift it by the whole amount, I shift it by half. so I can have that all halved. Okay, we can check that's working. If I have a card in play and I right click it now, it should now get super big and jump straight to the centre. There we go. It's handy in case we lose any health. We can see straight away what the health's changed to. Next, we need to add in this undo mega zooming code. So this one's fairly simple. We're just going to tell it to go back to being in play. And ages ago, we quite used to define the old position for when cards zoomed in from being in play. And important, because we brought this card forwards, we now need to send it backwards. Okay, so now if I right click again, that'll take the card back to where it came from. We're also going to have that same bit of code to run if I do my left click as well. Okay, so one last bit of code here. We're going to say if a card is in Mega Zoom and I left click it, it should go straight to my mouse. So let's get the mouse position. If I can just use a local mouse position for a change. So I need my X coordinate to be less than the apparent size of the card. So that is rectsize.x times rectscale.x, and also must be within the card's boundaries. So I'm using local mouse position, that is just greater than 0. And we have the exact opposite for the Y coordinates. So this means my mouse is on the card. If it is, we then want to go straight to in mouse. We need to give it a target scale, which will just be the size of the card slots. We use everything else. We're then just going to say setup is true. I'm not going to change my Z index here because it's already at +2, so it doesn't need to be +2 again where it was over here. And card select is false. And lastly, if I don't click on my card, then of course I want to undo Mega Zoom. Let's see if that's working nicely now. So card into play, if I right click, it goes big. If I click outside it, it goes away. If I click on it, it snaps straight to my hand. So the reason I can't attack straight from here is because I don't win the line of code. It says find some targets. So let's add that in now. I think I can just grab this bit of code here. Okay, it seems to be working fine. Everything's working pretty much as it should be. So I'm going to leave it there at the end of part 7. Hope that was helpful. And I will see you soon for part 8. As always, thanks for listening.